Good morning, everyone. Today we're going to be talking a little bit about box plots, which I personally like because they're part of statistics. These also get called box and whisker plots. They're a way of showing the information on a data set. They look sort of like this usually. Sometimes there's only one of them, sometimes there's more. It depends on whether or not you want to compare two groups. But before we get to that, we need a little bit of vocabulary so that we can even talk about what makes a box plot. For starters, the minimum. For the definition, you can start by putting S/E, that means self-explanatory. It's just the lowest value in a data set. The maximum, also fairly self-explanatory. Also S/E. So if the minimum is the lowest value, what do you want to think the maximum probably is? Yeah, the maximum is the highest value in a data set. Now here's one that's a little less obvious. Lower quartile. This also gets called aka quartile 1. As I was saying, quartile 1. And quartile 1 is a little less obvious than, say, minimum or maximum. Quartile 1 is the data point halfway between the minimum and the median. Not between the mode, not between the mean. It's halfway between the minimum and the median. You remember the median is when you arrange your data points from least to greatest. The median's right in the middle. So really, another way to think of the lower quartile is a median for the lower half of your data. And another important thing about the lower quartile, 25% of your data, of your data points that is, are between the minimum and lower quartile. Now for our upper quartile, aka quartile, it's not quartile 2 in case that's what you're thinking, it's quartile 3. And the quartile 3 is the data point halfway between the median and the maximum. It's essentially a median for the upper half of your data. And 25% of your data is between the median and the maximum. And quartile 1. And why we call them quartiles 1 and 3 is going to be a little more obvious once we see a box plot. So let's make one of those now. So let's say I've got a box plot. A box plot is one that looks something like this. Make sure that you get this diagram in your notes. One thing that you need to know about a box plot is that this spot right here, that's the median. Instead of writing that, I am going to type it. this one on the end right here. That one is your maximum. This one right here, that's the minimum. And then you see this right here, this one between the minimum and the median. What do we call that thing between the minimum and the median? Oh yeah, it's our first quartile, or our lower quartile, which, let's just abbreviate it and say Q1. And then this guy over here, what's halfway between the median and the maximum? Oh yeah, it's our upper quartile, also known as our third quartile, which we'll abbreviate as Q3. So now, everything in this box plot, or this box and whisker plot, is divided into 25% each. Right here, between the minimum and the first quartile, I've got 25% of my data. Then right here, between the first quartile and the median, that is another 25%. Then right here, between the median and quartile 3, or the third quartile, that's another 25%. And then finally, between the third quartile and the maximum, that is the last of my data. That's the remaining 25%. So now, I think I know one question you're going to have. You're going, okay, I get that quartile 1 is halfway between the minimum and the median. I get that quartile 3 is between the median and the maximum. Where's the second quartile? Well, the second quartile is kind of an obscure vocab term because the second quartile is really just another way of saying the median. So if you want to look for quartile 2 ever, it's just the median. And there's a third quartile too, meaning the very end. That's just another word for the maximum. So you can also think of the maximum as quartile 4 because really it is the fourth quartile, but we usually just call it the maximum. Now there's one last obscure part of a box plot. One last piece of a box plot that doesn't get used too often. You remember how we said, well, sometimes you'll include an outlier, sometimes you won't. There's a way you can do both at the same time on a box plot. Let's say I've got some huge outlier, way beyond what I would want to consider my real maximum. I can put an asterisk way beyond. It shows that this is an outlier out here. And then I can just put whatever the value of it was. Like if this was a data set that mostly went from $1 to $5, and there was some outlier of $25,000, I could put an asterisk outside of the maximum and go 25,000. Ugh, all of my zeros look like sixes today. So let's look at an example of a box plot that actually has some values on it. Make sure you have this diagram in your notes. Let's look at this example. Let's say there are two different groups of people visiting a national park. Yarg, I just want bigger font. And these box plots show the number of days each group, each person in the group spent at the park. So let's make a number line that goes from 0 to 5 days. Alright, so let's say one person in this group didn't spend much time there. They only spent 1 day at the park. That's my minimum. Another person, they spent a decent while there. They spent 4.5 days at the park. That's going to be my maximum. Also, I'm going to include halves in this box and whisker plot. Now, the first quartile, meaning in between the 25% of the data of the people in the group, is between the minimum and the first quartile is 2. So 25% of the people spent between 1 and 2 days there. The third quartile is 4. So 25% of the people spent between 4 and 5 days there. And the median, or second quartile, even though it rarely gets called that, is 3.5. 25% of my data is between 2 and 3.5 because that's between the lower quartile and the median. Another thing we can have is we can have more than one box and whisker plot on the same number line so that we can compare groups. This is group A, right? Excuse me, group B right here. Now group A, they did it a little bit differently. One person only spent half a day at that national park. Somebody else spent 5.5 days. So we can see their minimum and their maximum are bigger. Their first quartile was the same. Their third quartile was higher at 4.5 days, and their median was 3 days. And these are the two groups that visited the national park. Each box and whisker plot is different because the two groups had different people that spent different lengths of time there. This one, it looks like group A up here. It looks like, on the whole, most of them spent a little bit more time because you see between their minimum and their first quartile, well, yeah, one of them spent less time there than somebody else, but most of that first 25% is in the same area. But the 75% of their box plot that goes from the first quartile all the way to the maximum, meaning everything but this little 25% here, it goes further. So if I had to just pick these people's names out of a hat and guess, based on which group they were in, who spent longer at those parks, it would probably be the ones in Group A. Because even the maximum of Group B is only at the third quartile of Group A, meaning 25% of the people from Group A spent more time than anybody in Group B spent there. Each one of these little segments is 25% of the group. Thank you.